I can't really imagine being away from the teaching because I enjoy that so much. I've been here 9 years, and prior to that I worked for 9 years at Hawkeye Community College in Waterloo, Iowa. What I did at Hawkeye was the same thing that I did here, and the reason that we moved is because I'm a Nebraska native and my husband had family here in Omaha. We would come back to visit every month or so, and every time we'd drive the 4 hours, we'd think, wouldn't it be nice if we lived back in Nebraska? And so I watched and waited, and a position opened up for a physics teacher, and it was kind of a no-brainer for me to apply for it. So when I applied for it, I always thought, well, there's my job. That's my position. I originally come from north central Nebraska. I was born in Bassett, Nebraska, a small town, and grew up in Ainsworth, Nebraska. It's in between Valentine and O'Neill. And went to high school there. When I was about in 3rd grade, I was an avid reader and I loved to go to the library. So I found a book in the library on stars. And I was fascinated with the constellations and the different types of stars, the white dwarfs and the red giants and the black holes, and it just fascinated me. So I think from that point I developed a love of astronomy and wanted to go into that. When I went to college, as an undergraduate, I went to Kearney State College. I got a scholarship to go there, and by the time I graduated, it was the University of Nebraska at Kearney. And I did my graduate work at the University of Nebraska at Lincoln. I got a master's in physics and astronomy. We had some amazing dark skies in north central Nebraska. And so I would often go out and look at the stars and try and find the constellations and get a pair of binoculars and see some of the star clusters and some of the amazing things and the planets and how they moved. But I also really liked the math part of it. I always enjoyed math and chemistry and the sciences. So when I ended up going to college and I said I want to be an astronomer, they said you need to be a physics major first. You really need to understand the physics of orbits and gravity and how stars come together and dust and all of that. So I got the basic background in physics and electricity and magnetism and quantum mechanics and all of that good stuff to understand what's going on in the heavens with the stars and the galaxies. Between the physics and astronomy, I have to say my heart belongs to the astronomy. That was the beginning, that was the emphasis that I had, that was what got me started in the sciences to begin with. However, physics is the basis for all of the sciences. Chemistry is the study of the physics of atoms. Biology is the study of the organic atoms, and atoms are, you have to understand physics to understand that. So whether you're talking about geology or meteorology or astronomy, it's all rooted in the physics. So I enjoy teaching that part of it as well, and some engineering principles, but yeah, the astronomy still really captures my interest. In terms of being a woman in a field dominated by men, I didn't really notice it until I got to graduate school. Then when I'm taking my advanced physics classes, the first day of class you look around and you realize, hey, I'm the only female in the class. Then you start to notice it a little bit. In the biological sciences, there's more women than there are men now. In physics, however, it's still less than 20%, and in the engineering sciences, even less than that. So there's a strong push in the community to get girls, younger girls, more interested and then staying in the sciences. There's a lot of talk about the leaky pipeline, getting young girls started in science, but they don't follow all the way through and get degrees and then go into the field. And there's a lot of reasons that are thought to cause that, but I think it begins with the motivation, getting the young students interested, not only girls but boys as well. I think we need more people in the STEM fields in general, but getting people excited about science and trying to figure out how things work. I think my favorite instructor from college as an undergraduate was a fellow named Dr. Don Carlson, and he was a physical science teacher. And what I loved about his classes was he very heavily relied on doing demonstrations in class. He would always have physics toys in his desk, and he would bring those out and show you how a top works, or try and come up with a riddle or something scientific that you have to figure out. And after being in his class, I realized that's the kind of educator that I wanted to be. I wanted to have something tangible, have some kind of demonstrations that kind of teased people's ideas about how the world works, and then try and get them to learn the science from that. As far as the technology goes in education, I'm a part of the iPad group here at the South Omaha campus. And I think that technology has made it a lot easier to teach in some respects. I've always been interested in technology and used technology, a ruthless user of technology, if you will. And I'm absolutely amazed with what's available now with the iPad apps, just for a few dollars, the computing power that they have and the information that students have access to at the swipe of their finger. New results coming back from the sun, images from the Hubble, information from satellites like the Kepler satellite and the exoplanet data that's coming out. And it can be downloaded instantaneously. You don't have to go to the library and look up in the catalog. So I think in some respects, it kind of spoils students because you don't have to work as hard to find the information. But because it's so much easier, you have to be careful not to get lazy and really try and understand what's going on with that. The newer technology allows students to be a little bit more sophisticated in their analysis. Perhaps I wouldn't use the word smarter as opposed to us older generation, but I think that it allows them to get away with doing less of the busy work. Like, for example, if you roll a ball and you're trying to look at a graph of its motion, before you would have had to have taken a pencil on a graph paper and mark out the points and then draw the line and then do the analysis. With the technology, you're able to just get the graph right away, and then you can spend more time on trying to figure out what it means than all the grunt work of getting it in the first place. I get a lot of responses, evaluations saying that my classes tend to be difficult. You know, physics is a difficult subject, but they say that I make the material accessible to them, make it easier for them to understand, and I think that that's a valuable skill to have as an educator, is trying to make difficult subject matter easier for students. The one thing that I want students to take away from my classes is a joy of science, a love of learning, and then just trying to figure out how the world works, realizing that it's not always easy, it's not always defined, it's not always the answer that's in the back of the book, but you have to be continually curious and wondering and trying to figure things out. Yeah, the part that I like best about teaching is when a student gets it. They maybe have been struggling for a while, they don't understand, and then finally it all comes together. They might pull in a little bit from their math classes, maybe something from chemistry, and then the real world, and then it just snaps. As well with the undergraduate research, getting a student to ask a good question and then figure out their own answer. They'll say, you know, what's the answer to this question? And I'll say, I don't know. You know, that's one of the best things that you can say is, I don't know, you have to go figure it out. And then once they figure it out, then they have that ownership of knowing that they're the ones that did that. They figured it out. They didn't learn it from somebody else. A favorite quote about science would be, the most exciting phrase you hear in science is not eureka, but that's funny. And that's by Isaac Asimov. Yeah, and with the ballooning, you know, we are going up to near space. So it's not outer space, it's not space, but it's a section called near space. And being able to test that on a periodic basis is pretty cool. Next year we're going to be working with UNO to do a high altitude balloon launch, and then their students are going to take the data live and then send that to NASA so that their students get an opportunity on manipulating data, and we will be helping with the launch for that. My name is Kendra Sibbernsen, and I teach physics and astronomy here at Metro.